Let us start with the another chapter, that is free damped vibration system. Now we'll see the derivation of dry friction or Coulomb friction. So here we are taking into consideration the frictional force which is opposing the motion. Now we are having a mass m and it is connected to the fixed end with the help of the spring whose stiffness is k. And here there will be the friction which will be taking place, which is opposite to the direction of the motion. So if this is the direction of motion, then this spring will offer the restoring force, that is k multiplied by x, and frictional force, which is always opposite to the direction of motion, is F is equal to mu r. Now this we have already studied in our mechanics. So if you draw the free body diagram for this, then we can say that these are the various forces which are acting. So if this is the direction of motion, restoring force that is offered by the spring is kx, frictional force is mu r, where mu is the coefficient of friction and r is the normal reaction, and inertia force, which is always opposite to the direction of the motion, that is mass into acceleration. So we can say that all these forces, they are acting in the same direction, so they are getting add up. So equation of motion is mx double dot, that is inertia force plus spring force plus frictional force, that is equal to 0. So if you start with this, then mx double dot plus kx plus f is equal to 0. Divide throughout by m. So it is x double dot plus k by m x plus f upon m is equal to 0. So we can say that this is nothing but, if you take k by m common from these two terms, then it will be, so here we don't have any k by m terms, so we have divided by k by m. So this step is important. So if you take k by m common from both these terms, then k by m and here x will remain, but as k by m term is not present in this term, we have divided by k by m, so that this k by m and k by m will get cancelled out, and again we will get f upon m. So this is the important part. So x double dot plus k by m plus x plus f upon m. This k by m, if you convert this division into multiplication, it will be m by k. And now you can cancel out this m from numerator as well as from the denominator. So we are left with x double dot plus k by m into bracket x plus f upon k is equal to 0. Now let us assume that this particular term is equal to x plus f by k. Let us assume that that particular term is y. So y dot will be equal to x dot. This term is constant, its derivative will be 0. Y double dot will be equal to x double dot. So we can replace x double dot plus by y double dot. So you can see this x double dot, we can replace it by y double dot. This x plus f by k we can replace by y. So our variable is now y instead of x. So we can say that in place of x double dot, it is y double dot plus k by m as it is, and this entire term which is present in the square bracket is y. So now we are having this expression which we can easily compare with the equation of simple harmonic motion. So comparing with simple harmonic motion, equation of SHM, it is x double dot plus omega square x is equal to 0. So omega square has to be equal to k upon m. So omega will be equal to square root of k by m. In place of omega, we can substitute 2 pi f. So f will be equal to 1 upon 2 pi square root of k by m in hertz. So this is the frequency of oscillation of that particular mass, which is having the frictional force opposite to the direction of motion and the spring having stiffness of